Okay, children, I hope you will have watched my partial fraction lesson, right? So here I'm now move into the another lesson, which is remainder theorem and factor theorem, and this is under the algebra part in our combined mathematics syllabus. Pure, the combined mathematics is divided into two parts, which are pure mathematics and applied mathematics. Under the pure mathematics, we have algebra, calculus, trigonometric, coordinate geometry, right? So the under the algebra part, so we have a special lesson which is functions, right? So under the function, we have a few more topics. Those are quadratic functions, right? And polynomial functions, right? Those are under the algebra. So today I am going to discuss one more special part, which is remainder theorem and factor theorem. I think hope you all have know. So what is a factor, right? So when you are dividing 10 by 5, so answer is 2 and the remainder is 0. So this is known as quotient. So this is known as divisor, and this is our remainder, right? When the remainder is getting 0, which means, so the divisor is a factor of this, right? It's a factor of 10. Once you divide 10 by 3, so it's 9 and 1. Here the remainder is 1 and the quotient is 3. The divisor is 3, and 10 is known as a function or something, right? 10 is divided by 3 and the quotient is 3 and the remainder is 1. Actually we can write 10 like 3 into 3, right? This one, and divisor into quotient. Divisor into quotient plus remainder, right? 3 into 3 is 9. 9 plus 1 is 10. So the answer is 10, right? So this is our function, this is our divisor, this is our quotient, this is our remainder, right? So likewise we can represent the value, right, using divisor, using remainder and the quotient, right? So this is the remainder theorem, right? So the only difference is we are dividing some function, right? We are dividing fx by x minus a, and the quotient will be psi x, right? So I assume the quotient is psi x, right? And the remainder is, I assume, which is r, right? This is remainder, this is quotient, this is divisor, this is my function, right? So then fx is equal to x minus a, right? X minus a into psi x plus r, like the previous case, right? 10 is equal to 3 into 3 plus 1. 3 into 3 plus 1, like the previous case. Therefore, this is known as remainder theorem, right? Remainder theorem. But normally, we are writing it like fx divided by x minus a, the psi x, and this is r. So fx is equal to x minus a psi x plus r. So this is the remainder theorem. So once r getting 0, so that theorem is known as factor theorem. Like 10 divided by 5, the quotient is 2 and the remainder is getting 0. Once the remainder getting 0, that means we are in the factor theorem. Once the remainder is non-zero, we are in the remainder theorem, right? So the same theorem, right, we have two different remainders. That is the basic idea about remainder theorem and factor theorem. Okay, let me discuss another example using so this is actually the long division. I think you all have done this in our foundation course, and I think hope you all have done the foundation course in mathematics, right? Otherwise you don't know some operations, some simplification, right? You all must have done the foundation course before you enter the combined mathematics. Otherwise you will be really mess, right? you will be confused, right? So this is the division, right? This is a polynomial functions. I hope you all have know that, because in partial fractions I told you these are polynomial functions, right? Polynomial functions. This is our divisor, right? Divisor. So I'm going to divide this polynomial function by x minus 2, right? Okay, let's divide it. So here x4, and I'm just putting x cube, and x4 minus 2x cube, right? These two getting cancelled, like here the answer is this subtracted by this, and it is 9x cube minus 6x squared plus 6 plus 1. And I just need to put 9x squared as well. 9x cube minus 18x squared. These two getting cancelled, and this minus this. So it's 18 and 12. 12x squared plus 6 plus 1. Right? And also I am putting plus 12x. So which is 12x squared minus 24x. Right, these two cancelling, and here this subtracted by this, then 25x plus 1, and I'm just putting 25x plus minus 50, right? So the answer is plus 51, right? So you can see our remainder is getting 51. It's not a 0. This is our remainder. This is our quotient. This is our quotient. This is our polynomial function. So I just notate it as fx, right? It has fx. Therefore, you can write our fx using divisor and the quotient x minus 2 into quotient x cube plus 9x squared plus 12x plus 25, right? And you have to add this remainder as well, right? So this is our function. So this is another type of writing our function using remainder theorem, right? If this 51 getting 0, so the whole process is known as a factor theorem, right? Now it's under the remainder theorem, right? The remainder theorem is we have some remainder, right? So this is the method of writing our answer, right? Okay, I hope you all have understood about remainder theorem, right? So actually this division is known as long division, right? So the long division is actually another process, right? Let's move to the examples, right? Okay, this is my first example. Here ax to the power 4 minus 3x cube minus 2x minus 3 is divided by x plus 1, and the remainder is 4. Find a, right? So we need to find a, right? So now we can use our remainder theorem directly. So what is our remainder theorem? So fx is normally divided by x minus a, and the remainder is psi x. Sorry, the quotient is psi x, the remainder is r. Here the sum, this is our polynomial function. We are dividing by x plus 1, and the remainder is 4. We have to find a, right? Now, so under this is equal fx equal x minus j psi x plus r, right? So how to write the remainder theorem to the equation? So this is the important thing. So this is my fx now. So you have to follow this formula. This is my fx. Write down fx. x4 minus 3x cube minus 2x minus 3, right? Which is equal to this is our divisor, x minus a, like x plus 1, and psi x, right? Psi x plus the remainder is 4, right? So we wrote the result using remainder theorem. Now I just need to find a, right? Here you can see this is a psi x, right? Psi x is not again like a function. We don't know anything about psi x, right? And no point of putting this psi x over here, right? Therefore I'm just going to remove that psi x, right? So what is the method of removing psi x? We can put, when x equal minus 1, when x equal minus 1, it is a minus 1 to the power 4, 3 minus 1 to the power 3, 2 minus x minus 3. Here it's getting 0 and this is 4, right? Then minus 1 to the power 4 is plus 1, which is a, minus 1 to the power 3, which is minus 1 into minus 3 is plus 3, which is plus 3. And also minus into minus is plus, then plus 2 minus 3 equal 4, right? So we can put, shift our these numerical values to the other side. Plus 2 goes to other direction, then a will be 2, right? So this is the answer that we are expecting. Alright, so you can see the previous example we divided by using long division, but now we are not using long division. We just put in our remainder theorem directly to find a. Okay, let's move to another example. You will feel this is very comfortable lesson, so you can easily understand the theorem behind the remainder theorem and factor theorem. Okay children, this is the next example. The function ax cube minus 3x squared plus bx minus 8 is divided by respectively x minus 2 and x plus 1. The remainders are 32 and 0. Find a and b. Okay, so the first of all you must have summarized the question like in this way, right? And also after that you can use our remainder theorem. Fx is divided by x minus 2, right? And I think the quotient is psi x and the remainder is 32. As well, fx is divided by x plus 1 and the remainder is psi 2x. Sorry, the quotient is psi 2x and the remainder is 0. Here you can see this is our factor theorem. Once the remainder getting 0, that's known. This is the factor theorem. So once the remainder is non-zero, this is the remainder theorem, right? Actually, the factor theorem is a subset of a remainder theorem, right? The only thing is the remainder getting 0, right? Therefore, the factor theorem is a subset of a remainder theorem, right? Now, I am just putting my remainder theorem. Fx equal x minus 2 psi 1x plus 32, right? Here, fx equal x plus 1 psi 2x plus 0. Right. Now we need to remove that psi 1 and psi 2 from our function. I am just putting x equal 2 to the function. This is f2, right? So here 0 and 32 is only remaining. Here I am just putting minus 1. F minus 1 equals 0. What is f minus 1? What is f equal f2? So f2 means you have to put 2 for the function, right? Put 2 to the function. Then it's a 2 cube minus 3 2 to the power 2 b2 minus 8 equal 32. So what is this? A to the power 3 means 8a minus 4 into 12. This is 2b minus 8 equal 32. Here it's 8a plus 2b equal 12 and 8 is 20. 20 on the other side. Then it's plus 20. Plus 20 plus 32 is 52. This is my function equation number 1. And also f minus 1. Here it's a minus 1 to the power cube minus 1 to the power square b minus 1 minus 8 equals 0. And 1 minus 1 to the power cube is minus 1 minus a. Minus 1 to the power 2 is also plus. Minus 3 minus b minus 8 equals 0. Therefore, a plus b equal minus 11. This is my second equation. A plus b equal minus 11. This is my first equation. 8a plus 2b equal 52. These are the equations that we have. I am just divided by 2, right? 8a become 4, 2b 26, right? And I am going to subtract 1 and 2 So this is 3a. 26 minus 11. 3a equal 20. This is 7. 37. A will become 37 over 3. So answers are little bit fractional. So doesn't matter. So B will be minus 11 minus 37 over 3 minus 37 over 3. So it's 67 over 3 minus 70 over 3 and plus 37 over 3. So these are the answers. Please you also try this, right? Sometimes there may be some mistakes, sometimes I'm getting wrong answers because of my calculations. You also can try it, right? So I'm getting these two answers. It is a little bit fractional, right? Not the whole answers. Doesn't matter. These are the A and B that we have found, right? So now I think you might have a little bit idea about how to using remainder theorem in appropriate way. You have to write the formula and substitute it, and the other important thing is you have to remove this psi 1 and psi 2. Okay. Okay children, let's move to another example. So the third example, x cube plus ax squared plus bx plus c, which is divided by x plus 1 and x squared minus 1. The remainders are respectively 2 and x plus 2. We have to find a, b, c. Three unknown terms. The previous example, we had two unknown terms to determine, right? So we had two different simultaneous formulas and we found it. We found a and b. So now the situation has been changed. We have a, b, c. The three unknown terms and three simultaneous equations to be determined. Okay, so I'm just summarize the equation that they given to us. X cube plus x squared divided by x plus 1. The remainder is 2. X squared minus x plus 2, right? So I'm just putting the remainder theorems for the both case. Fx divided by x plus 1, and this is my psi x, the quotient, and the remainder is 2. And fx is divided by x squared minus x, the quotient is psi 2x, and the remainder is x plus 2. And I'm just formulate the formula fx equal x plus 1 psi 1 x plus 2, fx equal x squared minus x psi 2 x plus 2. So after that I'm just putting minus 1 over here to cancel psi 1x, then f minus 1 equal to 2. And also we can put x equal 0, right? F equals 0, it's the whole process is 0 and 0 plus 2 is 2. F0 is 2. And also these two are only two formulas, and we have to find another formula. So what is that? Actually x squared minus x, you can pull x out, right? Then x minus 1 psi 2x and plus x plus 2, right? And also you can put x equal 1 for the formula, then the psi 2x getting 0. So then it will be f1, the whole thing is 0, and 1 plus 2 is 3. So this is my next equation. So 1, 2 and 3. We have three equations right now. So f0 means this whole thing getting 0, 0, 0, and the c become 2. f0 is 2. And if you are putting x equal 1, so f1, so it's 1, right? It's 1 and a, right? A, here it's 1 and a and plus b and plus c equal to the 3, right? So here then 1 goes to other direction, a plus b plus c equal to 2. So right now we have three equations, and also 2, the c has been found, it's 2. Okay, these are the things that we have right now, and I'm just putting 2, then a minus b become 1, and also putting 2, then a plus b becomes 0, right? I'm just adding these two formulas, so it's 2a equal to 1, a equal half, and the b become minus half. So C also we found as 2. So these are the answers for the third example. So then right now you can understand what I have done. What was it? So I formulated the all functions, right? All the remainder theorem, I formulated the remainder theorem, and we made 3 different equations to determine A, B, C separately. Okay, so let's move to another example. After doing that fourth example, I think you all will be okay with the remainder theorem. Okay, here we are. So example, 2x to the power 4 plus x cube minus x squared plus ax plus b is divided by x squared minus 1. The remainder is 2x plus 3. Right, we have to find AB. So I think it's again like the second example that we have done. So we have to write the remainder theorem. Fx is x squared minus 1 and the psi x, and the remainder is 2x plus 3, right? And also fx will be x squared minus 1 psi x plus 2x plus 3, right? Over here you can see x squared minus 1 can be formulated with x minus 1 and x minus 1 and x plus 1, right? Psi x 2x plus 3, here is fx, right? Right now I'm just putting x equal 1 and also x equal minus 1. What happens if you are putting x equal 1? So if 1 will be 0 and 2 equal 5. If 1 means 2 plus 1 minus 1 plus a plus b equal to 5, then a plus b will be 2. These two getting cancelled, 2 goes to other direction, it's now 3. So what happens if you are putting minus 1? So 2 minus 1 to the power 4 minus 1 to the power cube minus 1 to the power 2 minus a plus b equal to minus 2 plus 3. This is getting 0. Minus 2 plus 3 is plus 1. So here b minus a, here is plus 2 minus 1 plus 2 minus 1 and also minus 1. This is minus 2 will cancel, and here b minus a is 1. b minus a equal 1, a plus b equal 3. So therefore the answer will be b minus a equal 1, b plus a equal 3. When you are adding these two, a getting cancelled, 2b equal 4, b equal 2, right? Then a will be equal to mean a will be 1. These are the answers that we have found. Okay, right, so this is the remainder theorem basic identification, right? We have one more identification. This is special identification. So I will tell you the special identification, right? So under that remainder theorem, so I'm just added some homeworks to be done. You have to done these homeworks, right? You have to find the unknown terms and all using the remainder theorem, right? Okay children, let's move to the special identification of a remainder theorem. So what is the special identification? So the previous theorem, it is a remainder theorem. What was that? Fx is divided by x minus a, and the quotient is psi x, and the remainder is simply r. So the now special identification is tell you how it be r, and are there any different way of writing the remainder, right? So these things are discussing with the special identification, right? Assume this divisor, this is always, this divisor cannot be a linear, no? It can be quadratic, it can be cubic, right? Whatever, you should have the method of writing the remainder when this is getting different, right? So when this is changing, you have to understand the changing of r as well. So this is the special identification. Right now I am just putting fx, right, and I'm thinking the divisor is px. Px is some sort of another divisor, right? It can be linear, it can be quadratic or anything, right? So now the previous theorem is specifically they identified it as a linear, right? Now I'm not putting linear to over here. It can be linear or it can be quadratic, cubic or anything, right? And the quotient is, I'm just thinking psi x, and the remainder is not r, I'm just thinking rx. So what happening over here, assume the remainder, the order, right? The order of the function is n. So the order means the largest power that we have. The largest power is n. And assume the function, the px has the nth order, nth power, nth order. And what will happen always, this psi x, right? This psi x is n minus n order. And what happened to the Rx? Rx is always m minus 1. M minus 1 order. So this is the special identification of a remainder theorem, right? What happening? And other thing is n is always greater than m, right? Otherwise you can't divide by fx by px. Always n should be more than m. So if it is, assume if it is fourth order polynomial functions, and the function is second order polynomial function, so the fourth order is divided by the second order, then the remainder will be a first order. And also this getting 4 minus 2, it is second order, right? Right now you can understand when you are dividing n, right? This is first order, no? X minus z is first order, no? Then the quotient will be n minus 1, right? And the r is n 1 minus 1 is 0, no? 0 means this is a only constant. That is why we put in r, right? So the remainder theorem is discussing for the first order devices, right? It's not the mth order, it is first order. So here n is greater than or equal 1, but the special identification is really focusing when the divisor is more than one situations, right? So this is the special identification of a remainder theorem. So I will repeat the property that we have. The fx is nth order and the divisor is mth order. The quotient is n minus nth order, and the remainder will be m minus 1th order. So this is the special identification of a remainder theorem. Okay, let's look at an example. Assume you have a polynomial function which is x to the power 5 minus 3x4 minus x squared plus 5x plus 3, right? And I'm just going to divide by x minus 1 and x plus 1. X minus 1 and x plus 1. And I just need to find the remainder. So now we can see this is the quadratic, no, the second order, and this is our function which is fifth order, right? And the remainder will be first order. So what is the standard formula of a first order? That is ax plus b. This is the standard formula of the linear format, ax plus b. If it is cubic, this should be ax squared plus bx plus c, likewise. So here divisor is x, second order, the remainder is x plus b. And I'm just formulate my remainder theorem. Fx is divided by x minus 1, x plus 1. This is psi x, and the remainder is ax plus b. Right. Now we can write fx x minus 1, x plus 1, psi x, ax plus b. Here I'm just putting x equal 1. When x equal 1, f1 will be, this whole thing will be, when here it's a plus b. When you put in x minus 1, f minus 1 will be, this whole thing be 0 plus bn minus a. Plus bn minus a. f1 is, I have to substitute over here, so it's 1 minus 3 minus 1 plus 5 plus 3 a plus b. Here these two getting cancelled, 3 also cancelled, a plus b equal to 5. Here minus 1 minus 1 minus 3 minus 1 minus 5 plus 3 equal b minus a, 3 getting cancelled, minus 7 equal b minus a. So answers a plus b equal 5, b minus a equal minus 7. When you add in these two, a cancel, 2b equal minus 2, then b equal minus 1. So a equal 6. These are the answers of a and b. So the remainder will be 6x minus 1. So this is the remainder when you are dividing the polynomial function fx by x squared minus 1. Okay, so the other important thing is, if you are accidentally putting r or something to here, so your answers will be directly wrong, right? Because you can't put r once you divide in by a quadratic or something different divisor, right? So keep it your mind, always the divisor, if the divisor is second order or the third order, you have to put the corresponding remainder using our special identification. Okay children, let's move to another example. X to the power 4 plus 3x cube minus 2x squared minus x minus 1 is divided by x plus 2 and x minus 1. So we have to find the remainder. So the first thing is we have to write the remainder theorem. This is my fx now. X plus 2, x minus 1, and psi x, remainder is, you can see this is second order now. This is second order, which is ax plus b. So the remainder theorem will be fx psi x into x minus 1 x plus 2, and here it's ax plus b, right? So now to cancel the psi x, I am just putting x equal plus 1. So it's f1 equal a plus b, and also I am putting x equal minus 2, then it's minus 2, and b minus 2a, ax plus b, right? So once you put x equal 1 to the equation, so it 1 plus 3 minus 2 minus 1 minus 1 a plus b, right? These two getting cancelled, minus 3 plus 3 is 0, a plus b equals 0. This is my equation number 1. And what happens if you are putting minus 2? Then minus 2 to the power 4 plus 3 minus 2 to the power cube minus 2 to the power 2 minus 2 minus 1 equal b minus 2a, right? Minus 2 to the power 4 mean plus 16 minus 24, minus 2 to the power 2 is plus 4, plus 8 minus 8, and plus 2 minus 1 b minus 2a. So I have to simplify it further. So how it will be? Plus 8 minus 24 plus 1 equal b minus 2a. Right. I'm just going to erase the board. These are the formulas. So 9 minus 24 is minus 15, b minus 2a, and also a plus b equals 0, right? So I'm just subtract in this way. Plus 15 equal 3a. A is 5, right? A is 5 means b is minus 5, because the addition should be 0, right? So these are the answers. Then our remainder which is ax plus b, no? So now a is 5x minus 5. So this is the remainder, okay? So the whole thing, this whole process is completely depend on the special identification. Once the remainder is second order, once the divisor is a second order, then the remainder will be first order. So that is the behind the scene of the special identification. Okay children, thank you very much for being with us. So the next tutorial I am going to discuss remainder theorem and factor theorem part 2, and it is a little bit different because we are using the remainder theorem repeatedly applications and all, and also I'm going to discuss some past paper questions as well. But however, the 80% of the remainder theorem has been done. So now you can feel free to do some past papers, some TUT questions as well. Okay, so thank you very much. So we'll see our next tutorial.